Welcome to the ARINC 664 tester demonstration by iWave. In this video we will walk you through the key features and functionalities of this powerful product. This high-level block diagram illustrates the ARINC 664 tester. Users can easily configure the system through a GUI accessible via DisplayPort, allowing for configuration of communication parameters and virtual link configuration options. The ARINC 664 tester receives ARINC 664 data from the SFP-RX port and transmits the ARINC 664 frames through SFP-TX port. iWave's ARINC 664 tester is specifically designed for defense and avionics applications, offering a reliable solution to validate, test, and ensure compliance with the ARINC 664 standard in avionics systems. ARINC 664 tester runs on GUI that simplifies system configuration and control. Tooltips are embedded in each segment to provide contextual information when hovered over. The GUI framework includes built-in validation logic that actively monitors user inputs and provides immediate warnings or error prompts if any mandatory field is left blank or populated with invalid configuration parameters. One of the core features of the interface is virtual link configuration. Here one can enable or disable VLS based on the user requirement, and this section includes user-defined 2 bytes of virtual link IDs and bag values for each of the 8 VLs. User can select incremental data, PRBS data and input data file as a source either from local directory or from the network for each VL. The status option indicates the total number of ARINC 664 packets transmitted through that VL. Communication parameters option allows user to specify 6 bytes of source MAC address, 4 bytes of destination MAC address, 4 bytes of source and destination IP address and 2 bytes of source and destination UDP port number. Where user is also allowed to specify payload size ranging from 17 to 1471 bytes and MAC speed. User can transmit the packets either in one of the links or both by enabling and disabling redundancy management dynamically. Users are allowed to ensure the functionality of the IP by injecting errors at various segments of the ARINC 664 frame and by detecting these errors on the receiver side. Link Establishment component displays the link status of both redundant links. The Statistics window offers a GUI for ARINC 664 reception settings including selection of receiving VLID, receiving data pattern and packet statistics of each VL. This includes the total number of ARINC 664 frames received, redundant frame count, and number of frames dropped due to error in the frame. GUI also allows capturing the receiving data while user must specify file name and size. The separate error indication LED for each VL section of the statistics page indicates data integrity in the ARINC 664 payload, which is available for incremental and PRBS data. The error indication LED for all VL sections of the statistics page indicates which segment of the ARINC 664 frame contains error. The simulation window offers a GUI for live simulation by mimicking the sensor data using the widgets. A gauge meter displays a numerical range from 0 to 100 based on the user data, which will be transmitted over the selected virtual link. Each VL is associated with its VL ID and displays the number of total packets transmitted. To describe the operation of ARINC 664 tester, the ARINC 664 end system with a separate transmitter and receiver setup, we use 2 independent boards, one configured as the transmitting end system and the other as the receiving end system. Both boards are connected via Ethernet. The ARINC 664 tester GUI along with end system is launched on one board to simplify system configuration and monitoring, while the other board runs only the end system. A frame generator is set up with a defined payload pattern. Once the configuration is complete, the transmitter is enabled. On the receiving end system side, we load the matching VL table to expect the correct frames and enable reception. As frames are transmitted, the receiver captures them, and the tester GUI displays live data on frame counts, sequence number integrity, and bag compliance. The user can verify that received frames match transmitted frames in order, with no packet drops. The error indication LED for Virtual Link 1 represents a data integrity error. Whenever corrupted data is detected, the LED glows to red. Data integrity checking is supported for both incremental data and PRBS patterns. In the error indication LEDs for all Virtual Links panel, each LED represents one layer, IP, UDP, MAC, and sequence number. Whenever an error occurs in any of these layers, the corresponding LED will glow red. If errors occur in multiple layers, the LEDs for those layers will light up to red simultaneously, providing a clear indication of faults across the protocol stack. The user can also capture the received data by specifying the file name and size ranging from 1 KB to 8 KB, and additionally view the captured data in the file. The link establishment indication panel shows the real-time link connection. The LEDs represent Network A and Network B. When a link is successfully established, the corresponding LED glows green. If the link is removed or lost, the LED turns red, providing an instant visual status of connectivity. In addition to ARINC 664 tester solutions, iWave also offers ARINC 664N system IP core optimized for FPGA or SoC integration, delivering deterministic and reliable avionics data communication. Key features of ARINC 664N system IP core. You can check the iWave website for more details on ARINC 664N system IP as well as other FPGA IP core offerings from iWave.